Okay, in today's video, we're going to do the law of cosines. So you need information about area of a triangle, and that information is in yesterday's class video on law of sines. So look to Monday's video for that. Okay, so I'm going to start with law of cosines, but the homework has 3 problems in area using 1/2 AB sine C. So go back and check on your notes and the video that goes with it under law of sines. Okay, so in our last section, we saw that you can use law of sines if you have angle, sine, angle, or angle, angle, side. That's when you can use law of sines to solve for triangles. Sometimes you will not have that. And without the right set of elements, your law of sines is not going to work. So we're going to consider 2 other scenarios and show you that you're going to use law of cosines there. Okay, so for one, if you are looking at a situation where they give you side, angle, side, and you would try to do law of sines, look what you're going to see. You're going to see that here's your setup, a side, and an angle. I don't have any kind of pairs to start off having a proportion, and therefore I can't use law of sines. Let's say that you're given side, 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 which is all 3 sides, and you try to use law of sines. You're going to be getting these pieces of your ratios, but not a full proportion because you have no angle. So therefore you're not going to be able to use it. You need another tool. The other tool you need is called the law of cosines. So you use law of cosines for one when you have side, angle, side, and law of sines is not going to work. Okay, so let's go and look at an example of law of cosines. So you are given the following information. This is case 1, 2 sides and the included angle. So this little triangle up here to the left, I'm going to use that to annotate the information given here. So I have lengths of 3 centimeters and 7 centimeters, and I have an angle between them, which is also called the included angle, of 135. So I'm going to put 135 right here at B, and then I'm going to make this A, opposite A will be the 7, and opposite the C will be the 3. Okay, so this is what I have. This is the given information. It is a side, it is an angle, it's an included angle, and it's another side. Side, angle, side, the classic case that's going to require using law of cosines. So our job, the first thing we're going to do is we're going to find the side opposite the given angle. So the given angle was angle B, so I want to find little b. So I'm going to use the second variation of the law of cosines. I'm going to give you all these laws. Your job is going to be to apply it. So I'm going to say, we're going to use this one, b squared equals a squared plus c squared minus 2ac, the cosine of that given angle. Okay, because I want b, I know that I'm going to have to take the square root of this whole expression. So my a squared is 7 squared plus my c squared is 3 squared minus 2 times 7 times 3 times the cosine of 135. Remember, you always have an open paren when you type in cosine, and your job is to close it at the end of your angle. So just do that all the time. If you put this in your calculator, and I would highly encourage you to practice doing this with me, you should be getting 9.4 for the side that you just solved for. That was B. I'm going to put 9.4 right here, and I'm going to highlight it in yellow so that I know that I started, that I had to solve for that side. It was not given to me. Okay, this is really critical. I want to find some more pieces of this triangle. My focus has to be on the smallest angle. So I'm going to look there first, and I want to switch over to the law of sines because it's a lot easier, and I have it written up here for you. So you have to focus on the smallest angle because there is something with law of sines called the ambiguous case, and we have skipped that. So in order to not fall into the ambiguous case, which is explained in the textbook, you're going to avoid that by following this major rule. When you switch from law of cosines to law of sines, you're going to look for the smallest angle. The smallest angle is always across from the smallest side. So I want to find angle C. So angle C is what I want to find because it's across from the 3, which is the smallest side. So let's set up our proportions. Well, since I found the side opposite 135, this is why I can use law of sines. That's going to equal the sine of angle C, which is unknown, over 3. Do your cross products. 3 times the sine of 135 equals 9.4 times the sine of C. Divide both sides by 9.4. Okay, and you're going to get sine of C. I don't really want sine of C. I want C. So I'm going to say C is going to equal sine to the negative 1 of this expression right here. So I'm going to copy that expression and put it right here. Okay, make it a little bit smaller so that it can fit right there. Okay, that's what goes in my calculator. So this right here in the orange box, this piece of it goes in my calculator. Okay, let me get rid of some of that extra orange. Okay, so I'm going to say second sine, which gives me sine to the negative 1. I'm going to write in 3 times the sine of 135. Close those parens around the angle. And then divide that by 9.4. Do it in one fell swoop. That will give you the angle C, and you should be getting angle C is 13 degrees. Okay, so let's put that 13 right here, and I'm going to highlight it in yellow because I know I had to calculate that. We have one more angle to get, and you're just going to get that angle by saying 180 degrees minus the angle they gave us, which was 135, minus the angle we just found, which was 13, and that's going to equal 32 degrees, and therefore angle B, which is our remaining angle, is 32 degrees. So let's go ahead and we'll put that in there too. And I'm sorry, this is angle, I'm so sorry, that should be angle A. So let me change that because the way I wrote it here, that's going to be angle A. That's what I want to find. And angle A was 32 degrees. And it's right in here. And again, since I had to solve for it, I'm going to highlight it. So I was given 3 pieces, sine, angle, side, and I had to solve for 3 pieces. And I used law of cosines to begin, and then I switched over to law of sines. Okay, let's go ahead and we'll do the next problem. This is another side, angle, side. So we're going to have another little practice. So to do that, let me just switch my pages. Okay, I'm going to illustrate this little triangle. So the A is going to be the 36 that they're giving me. So this is 36 degrees. And the 2 sides are 18 and 11. Okay, so that's side, angle, side. I'm going to first find the side opposite the given angle. So that's going to be find side A. Okay, so I'm going to use this formula. So I know that formula is A squared equals B squared plus C squared minus 2BC cosine A. Since I want A and not A squared, before I even touch the calculator, I'm going to do a square root symbol. And my B is 18, so that's 18 squared plus 11 squared minus 2 times 18 times 11 times the cosine of the given angle of 36 degrees. When I put that in my graphing calculator, I'm getting a value of 11.2, which is a side. So this is side A. It is 11.2. Okay, so that's our first thing that we've discovered. There you have it. Now I have an angle across from the side. I can switch over to law of sines as long as I make certain to find the smallest angle. The smallest angle will be angle C because it is across from the angle, the side length of 11, which is smaller than the side length of 18. Okay, so I'm going to switch to law of sines. Take the information that was given you, which was sine of 36, with the side that we found first using law of cosines, and that's going to equal the sine of angle C, which is what we're looking for, over its opposite side. Okay, so 11 times the sine of 36 equals 11.2 times the sine of C, divide by 11.2. Okay, that's going to give me sine C. But I don't want sine C, I just want C. So in my calculator, I'm going to say C equals, I'm going to put in sine -1 of 11 times the sine of 36, open and close those parentheses, divided by 11.2. Close those parentheses, put that in your calculator, hit the old enter button, and you should be getting 35.3. So angle C equals 35.3, and that's degrees. Okay, so this is 35.3, which is right here, 35.3. I'm going to highlight that in yellow. And now I'm missing one other angle. And I'm going to say 180 degrees minus 36 degrees minus 35.3 degrees. And that's going to give me a value of 108.7 degrees, which is indeed across from the biggest side, so that makes sense. Okay, and highlight that. All right, so we've done two examples of side angle side. I started solving with law of cosines. I found the missing side opposite the given angle, and then I switched over to law of sines, and I was able to do that because my focus was on the smallest angle. Then I used subtraction to get the remaining angle. Okay, there's one more quick little practice here. So this is an application. They want you to find the distance between the flag and the ball. So the distance between the flag and the ball. So I'm going to make this, let's see, we'll label things. I'm going to make this A, this B where the marker is, and this C where the ball is. So what do I notice? They have given me side, included angle, and side. That is another side angle side. All I need to find is little side B because that's what they want when I read the problem. Okay, and you should read this problem because it's interesting, and I'd like you to make sure that the reading goes along with the picture and that you could have developed this picture if I had not given it to you. Okay, to find little side B, I'm going to use the B equation, which is here. Okay, so I'm going to say b squared equals a squared plus c squared minus 2ab, ac, ac cosine of b. Okay, so once again, I don't want b squared, I want b, so I'm going to go immediately into the square root. So my a side is 35 squared, my c side is 150 squared, minus 2 times 35 times 150 times the cosine of the given angle, which is 110 degrees. Okay, that goes in my calculator, and you should be getting 165.3, and the measurements are in yards, so when you finish your problem, you should give them back yards. Okay, so another side angle side. All right, so the time has come to handle problems that give you side, 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 and you need to find everything else. So what we're going to do is this. Okay, we're going to take this form of an equation as an example and convert it to an equation that will find my angle. So look where I am on the left. What if I were to add 2bc cosine A to both sides? And subtract a squared from both sides. That would give me 2bc cosine A equals b squared plus c squared minus a squared. Divide by 2bc, divide by 2bc, and you get cosine A equals b squared plus c squared minus a squared over 2bc. And that is exactly what we have written right here. So when you're asked to find an angle, we are in effect using the equation of cosine, the law of cosines. But we're switching things around. We will give you all three of these formulas and all three of these. But I needed you to see that I just didn't create this. I just transformed the original equation that I was working with. And we can do that for b squared and c squared as well. So you don't need to know how to do this. You just need to understand where it came from so that you're feeling confident using law of sines, whether it be for finding a side or finding an angle. Okay, so with that, let's try to do our three sides example. So here they give me sides of 6, 12, and 15. I am going to put my A, B, and C here, and I'm going to make this 15, this 6, and this 12. Okay, so we have all those there. Okay, sorry about that. Hopefully we'll come back on. Let me see. Okay, so give me a second to fix this. Okay, sorry for that interruption. All right, so we'll be given side, side, side. Our first step is to solve for the largest unknown angle. That's going to be across from the largest side. So I am looking for angle C. So looking for angle C, I'm going to use cosine of C equals a squared plus b squared minus c squared over 2ab. So again, I don't want cosine of C, I really want angle C. So I'm going to take the cosine to the -1 of, and my A is 6 squared, plus my B is 12 squared, minus my C is 15 squared, over 2 times my A, which is 6, times my B, which is 12. That goes in my calculator. Now, super, super important. When you're entering this, your numerator should be in parens, unless you're using that fraction feature of the TI-84s. Your denominator is also in parens. If you don't do this, PEMDAS is going to give you the wrong answer. So try to do your input. You should be finding that angle C is going to equal 108.2. Okay, I'm just going to move this guy over a little bit. Okay, so there's your angle C. Now, let's go ahead and fill that in. And this is 108.2. 108.2, and I'm going to highlight it in yellow so that I know that I have solved for the missing angle. And I'm going to use the alternate approach. I'm going to find the other angle using law of sines, but if I'm going to do that, I have to go for the smallest angle. All right, so what's my smallest angle? I should be looking at angle A because that's across from the 6. So here's my proportion. Sine of the angle I just found over the side opposite that angle, which is 15, equals the sine of the angle I'm looking for over the side opposite that angle. Okay, here's your first step. 6 times the sine of 108.2 equals 15 times the sine of A, divide by 15, divide by 15. Now, that's what gives me sine A, but I don't want sine A, I just want A. So A equals sine to the -1 of 6 times the sine of 108.2, remember, open and close those parentheses, all over 15, and that gives me an angle value of 22.3 degrees. Now, over here, I could have, so this is the other version, I could have used cosine A equals, and it would have been b squared plus c squared minus a squared over 2bc to find angle A. Either way, I would have looked for the smallest angle next. Okay, so step 3, which I didn't write down, so I'll put that in red, is going to be to find the missing angle. So take your 180 degrees minus the first angle we found, minus the second angle we found, and your missing angle, which is angle B, should equal 49.5 degrees. Okay, so this one is 49.5 degrees. And I had found that one. And the other one was 22.3. 22.3 degrees. And I have that one. Okay. So there we have it. So we've practiced side angle side, we've practiced side, 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 and we've been incorporating using law of sines once we find one missing element. Okay, what else do we need to know? We will give you all, just turn this red, we will give you all of these, we will give you all of these. We will give you that sine A over A equals sine B over B equals sine C over C, and we will give you area equals 1/2 AB sine C. I believe you need to know SOHCAHTOA and basic things like there's 180 degrees in a triangle, like those kind of basic things that we've known. So you will be able to practice this next class, but go through the homework now. The first 3 problems are area. The next problems are law of cosines. Remember, you can use law of sines. After that, provided that you always look for the smallest angle. Other things to keep in mind, read in 5.3, that one page gives you the area of a triangle using that sine feature. The other reading is in 5.6, and you can ignore Heron's law, and you can also ignore the navigational information that they give you about bearing. Okay, everything else is good to read. Check your answers in the back of the book because they're odd problems. Come see me prior to class if you can't solve something. Okay, thank you very much.